finding the solution for a system of linear congruences in two variables. Here is a first problem. Find the solution of system of linear congruences 7x plus 3y congruent to 10 modulo 16, 2x plus 5y congruent to 9 modulo 60. Here they have given a system of linear congruence in two variable x and y. So first take the solution. Here we have to consider these two congruency and find the value of a, b, r and c, g and s value, also m value. Here from the first congruency, a value is 7, b is 3 and r value is 10. Similarly, from the second congruency, c value is 2, d value is 5 and s value is 9. Also under modulo 16 means we get a m value as 60. Here this is a very important step. First you have to take a, b, r value, c, d, s value and also m value by the given problem. Next step, you have to take a given two equation and call first congruency as equation 1 and second congruency as equation number 2. Next, what's the first step? We have to find the GCD for a, b and this m. Also we have to find the GCD for c, d and the value m. So that is, we have to find the GCD for 7, 3, 16 and we have to find the GCD for 2, 5, 16. Here we already discussed in a previous video how to find the GCD in a simpler way. That means here we have to find the GCD for this value means we have to find the divisor for all these values. Among these divisors, we have to find the greatest common divisor is nothing but a GCD for this value. So first take this value, that is, first you have to find the divisor for 7, that is divisors of 7 is 1 and 7 itself because 7 is a prime number. So the divisors of 7 is 1 and 7 itself. Similarly, you have to find the divisor for 3. Here divisor of 3 is 1 and 3. This is because 3 is a prime number. So the divisors are 1 and the number itself. Next you have to find the divisor for 16. Here divisors of 16 are 1 divides 16, 2 also divides 16, 4 divides 16, 8 divides 16 and 16 divides 16. Here we have to take the divisors of 16, that is the numbers which divide the value 16. Here 1 divides 16 is nothing but 16 divided by 1 is 1 ones are 1 16 is 2 divides 16 is nothing but 16 divided by 2, 2 ones are 2 8s are 16. Here 4 divides 16 is nothing but 16 divided by 4 wholes. In the similar way, you have to find the divisors of 16 is nothing but 1, 2, 4, 8 and this number 16 itself is a divisor of 16. Next, these three are the divisors of 7, 3 and 16. Among these three, we have to find the greatest common divisor, that is a GCD of 7, 3 and 16. Here we have a common divisor in these three are only 1. Here this is 1 and 7, this is 1 and 3 and this is 1, 2, 4, 8 and 16. Among these three, the common divisor is 1. That 1 is the greatest common divisor because it has only one element, that is 1. So among these three, the greatest common divisor is nothing but 1. Therefore, we can conclude that the GCD of 7, 3 and 16 is 1. In the similar way, we have to find the GCD of 2, 5 and 16 is nothing but we have to find the divisor of 2, 5 and 16. Among these three, we have to find the greatest common divisor. So first we have to find the divisor of 2. We know that 2 is a prime number, so the divisors of 2 is 1 and 2 itself. Similarly, 5 is, the divisors of 5 is 1 and 5 itself because 5 is a prime number. Also, the divisors of 16 is 1, 2, 4, 8 and 16. Among these three, the common divisor is 1. Also, the greatest common divisor is also equal to 1. Therefore, we can conclude that the GCD of 2, 5 and 16 is equal to 1. Here we are verified the GCD of 7, 3, 16 is 1 and also the GCD of 2, 5, 16 is equal to 1. Also, we have to verify the condition, that is the GCD of AD minus BC comma M must be equal to 1. So, we have to take the multiplication of A and D minus the multiplication of B and C. We know that A is 7, B is 3, C is 2 and D is 5. Therefore, AD minus BC is nothing but A is 7, D is 5, 7 into 5 is 35 minus B into C. B is 3 and C is 2, 3 into 2 is 6. That is 35 minus 6 comma M is 16. So, we have to find the GCD of here 35 minus 6 is 29. So, we have to find the GCD for the value 29 comma 16. That is the GCD is nothing but we have to find the divisor for 29 and 16. So, we know that divisors of 29 is 1 and 29 because 29 is also a prime number. So, the divisors of prime number is the number 1 and the number itself. Therefore, we can conclude the divisors of 29 is 1 and 29. Similarly, the divisors of 16 is 1, 2, 4, 8, comma 16. Among these two, the greatest common divisor. First, we have to find the common divisor. Here, 1 is a common divisor in both. Therefore, we can conclude that the greatest common divisor of 29 and 16 is equal to 1. Therefore, we have shown that the GCD of AD minus BC, comma M value is also equal to 1. Again, you have to verify the condition. the GCD value, that is AD minus BC comma M, GCD divides the value M. Obviously this value is 1. Obviously 1 divides M. Here small m is 16. 1 divides 16 holds. Therefore we can conclude that the system has unique solution. Here first you have to verify that the greatest common divisor for A, B and M and the greatest common divisor for C, D and M value is 1. That is they are relatively prime. Also we have to find the AD minus BC value. The GCD of AD minus BC value with the small letter M is also equal to 1. That is the GCD of AD minus BC comma M must be equal to 1. That is they both are relatively prime. Also we have to verify the condition AD minus BC comma M divides the value M. If all the condition holds, therefore we can conclude that the system has unique solution. Next we have to find the value of X and Y. In previous videos, once we conclude the system has unique solution, we are finding the value of X. But in this we have to find the solution for two variables X and Y, because here we have two variables X and Y, so we have to find the value of two variables X and Y here. For that we have to consider equation 1 and equation 2. That is, here we have to find X and Y value, means we have to consider the given linear congruences, that is given system of linear congruences, that is they have given 7x plus 3y congruent to 10 mod 16 and 2x plus 5y congruent to 9 mod 16. Here from these two linear congruences we have to eliminate once the x value and we have to once eliminate the y value and finally find x value and y value. That is, here in the first linear congruence we have 7x plus 3y congruent to 10 mod 16. Here second linear congruence is 2x plus 5y is congruent to 9 mod 16. So we can't cancel x term and y term. So to cancel x term or y term, for this linear congruency we have to multiply some value. Here we have 7x plus 3y. Here if we multiply this congruency by 5 and if we multiply this congruency, second congruency by 3, here we get 3 into 5 is 15. Here we have 5 into 3 is 15. So we can cancel the term y. So we have to multiply 5 for the first linear congruency and we have to multiply 3 for the second linear congruency. The linear congruency changes to, here first congruency changes to, here if you multiply throughout by 5 means 7 into 5 is 35x plus 3 into 5 is 15y is congruent to 10 into 5 is 50. Under mod 16 does not changes, it remains as it is, that is mod 16. So if we multiply for this linear congruency by 3, we get a congruency value as here 2x into 3 is 6x plus 5y into 3 is 15y congruent to 9 into 3 is 27 under modulo 60. So now we can easily cancel 15y and 15y by subtracting these two linear congruency. Next step, we have to subtract first congruency by second congruency. We get here we have 35x. Here this positive sign changes to negative sign. So 35x minus 6x, we get a value as 29x. Here plus 15y, here plus into minus 15y. So we can cancel this plus 15y minus 15y. So we get a 0 is congruent to, here we have 50 minus 27. So 50 minus 27 is 23 under modulo 16 as it is. So if we cancel these two terms, the remaining value is 29x congruent to 23 mod 16. Next step, already discussed in the previous videos how to find the x values using the definition of congruency method. Here we have 29x congruent to 23 mod 16. We can write by the definition of congruency as 60 divides 29x minus 23. Or we can take this as 29x minus 23, which is equal to 16 into some integer k. This is because from the definition of congruency we can write like this. Next step, you have to take minus 23 to the right hand side and this 29 goes to the denominator. We get a value of x as 16k plus 23 divided by 29. Here, so this is a value of x. From this we have to find the x value by substituting k value as 0, 1, 2, 3 etc. and we have to obtain an integer value for x. So first step, we have to put k value as 0. If you substitute k value as 0 means 16 into 0 is 0 plus 23 by 29. Therefore we get x value as 23 by 29. That obviously does not belong to an integer z, because integer z means it contains a value 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. up to infinity. It does not contain a fraction value, so it does not belong to z. Next you have to put k value as 1. If you substitute k value as 1 means 16 into 1 is 16 plus 23 divided by 29. Therefore we get x value as 39 by 29. Obviously 39 by 29 also does not belong to an integer z. So we have to put a k value as 2. So if we put k value as 2 means 16 into 2 plus 23, we get a value as 55. Therefore x is equal to 55 divided by 29 also does not belongs to an integer z. Next you have to put the value k is equal to 3. If you substitute k value as 3 means 16 into 3 is 48. 48 plus 23, we get a value as 71. That is x value is equal to 71 divided by 29 also does not belongs to an integer z. Next you have to put a value as k is equal to 4. If you substitute k value as 4 means 16 into 4 is 64 plus 23, we get a value as 87. That is x is equal to 87 by 29. If we divide 87 by 29, we get a value as 3. Therefore we can conclude that x is equal to 3 belongs to an integer z. Hence we can conclude that x is congruent to 3 mod 16 is a solution. Here once you obtain x value as an integer, so we have to stop the procedure and we have to consider x is congruent to that value under mod 16 is a solution. Here we find x value as 3. Also we have to find y value. For that, next step is we have to put x is equal to 3 in equation 1 or equation 2. Here we have to put x is equal to 3 in a given linear congruency. So we get here equation 1 is 7x plus 3y congruent to 10 mod 16. Equation 2 is 2x plus 5y congruent to 9 mod 16. We can substitute x is equal to 3 in equation 1 or equation 2. Both are same. So I am taking equation 2 and substituting x value as 3 here. Here 2 into x is 3 plus 5y is congruent to 9 mod 16. Here we get 5y plus here 3 to 2 is 6 is congruent to 9 modulo 16, or we can take this as 5y congruent to, here if we can subtract this congruency by 6, we get 5y plus 6 minus 6 is congruent to 9 minus 6 mod 16. Therefore we get plus 6 minus 6 gets cancelled. We get 5y is congruent to 9 minus 6 is 3 modulo 16. Therefore we get a congruency value as 5y is congruent to 3 mod 16. So here next the procedure is same as before. Here we have to apply the definition of congruency as, here this implies 16 divides 5y minus 3, or we can take this as 5y minus 3 which is equal to 16 into some integer k, or we can take this as y is equal to, here we can take this 3 to the right hand side and 5 goes to the denominator, we get y as 16k plus 3 divided by 5. Next step we have to substitute k value 0, 1 to 3 and we have to obtain a y as an integer. So first step we have to put k is equal to 0. If we substitute k value as 0 means we get y value as 3 by 5. Obviously it does not belongs to an integer z. Next you have to put k value as 1. We get here if we substitute k value as 1 means 16 into 1 is 16 plus 3 is 19 by 5. Therefore y is 19 by 5 does not belongs to an integer z. Next you have to put k is equal to 2. If we substitute k value as 2 means 16 into 2 is 32. 32 plus 3 is 35. Therefore we get x value as 35 by 5 which is equal to 7. 5 ones are 5 sevens. Therefore we get y as 7 does belongs to an integer z. Therefore we can conclude that y is congruent to 7 modulo 60. Here we get a solution as x is congruent to 3 mod 16 and y is congruent to 7 mod 16. Therefore these two are a solution for a given system of linear congruences. Here in the previous videos we get only one value because it depends on one variable x, but in these problems are related to finding the solution of system of congruences in two variables x and y. So we get a solution for x and y in two values, that is x is congruent to 3 mod 16 and y is congruent to 7 mod 16 is a solution.